Hello, and welcome to Aerotech's Automation1 Motion Control Platform Educational Series. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors and other devices. In this video, you'll discover what the command queue feature is and how it operates within the Automation1 software. My name is Alex Smoker, and I'm a control systems specialist for Aerotech. Let's begin with what the command queue feature actually is. Command queue is, at its core, simply a feature that allows the Automation1 controller to queue up multiple AeroScript commands in a buffer and then execute them at a later time, hence the name command queue. This command queue mode also gives us the ability to issue consecutive commands rather quickly or to run AeroScript programs that may be too large to compile and run in the normal programming interface of Automation1 Studio. Now, for those of you who are migrating from Aerotech's legacy software like A3200, let's touch on how this compares so that you can get an idea of how this might replace your current solution. If you are not worried about migrating to Automation1 software from an older Aerotech solution, then feel free to skip ahead. Plainly put though, the command queue feature is a replacement for A3200's queue mode, more commonly called the programmed buffered run feature. While this is an update for the PC-based controller, it is an entirely new feature for standalone drive-based solutions such as the iXC4E or the iXR3 and many others. This affords us the luxury of being able to run large programs, sometimes on the order of gigabyte in size, from a simplified drive-based controller solution. The reason we bring this comparison up is to highlight the primary difference between the older A3200 legacy solution and the newer Automation1 architecture. The Automation1 command queue is primarily an API-driven tool that utilizes the APIs to load and manipulate the queue. So to use this feature, you will first need to use the Automation1 APIs such as C or .NET. Similarly to A3200, however, the queue can be started, stopped, and paused from within the normal Automation1 Studio environment. You just cannot load new commands into the queue from within an Automation1 Studio script. So why do we need this in the first place? Well, when you execute non-queued AeroScript commands through the C or .NET API, a fixed quantity of overhead delay occurs when executing the commands sequentially one after the other. This delay usually averages from 3 to 5 milliseconds based on the performance of the PC, and you also have to include all the network latency delays that might occur on top of that. The command queue feature lets us queue up multiple commands in the controller to prevent this overhead and delay. So if this delay is not acceptable for your process due to the application, then the command queue feature may be used to prevent this overhead. The main appeal, however, of using command queue is its ability to execute large chunks of commands without needing to compile the commands as a singular program. Take this example for instance. I have a program that is a measly 1,000 lines long. The time it takes to compile that into machine code and for the system to run that would take milliseconds if not faster to do. You won't notice that amount of downtime when you're writing your program and compiling it. But now imagine that I increase that to 100,000 or even a million moves long. That exponentially increases the time it takes for my program to compile. Effectively what this means is that by using command queue, we are able to load the command queue buffer with those lines from a very large program, or in chunks from that very large program, and then compile and execute those lines as we go in smaller chunks, without needing to compile the whole code itself. This method drastically reduces the cycle time of running a large program by eliminating that downtime that we would otherwise have to use for opening and compiling the code itself. And while this may not seem like a big deal for smaller, more manageable programs, with more complicated applications like 3D printing or machining that may require upwards of thousands if not hundreds of thousands of individual program lines for a single part, then this feature does greatly help in handling those kinds of situations. Well, with all of that background information on what command queue is and why we use it, let's look at some of the programming itself. Now, before we touch on that, I want to look over some of the basics of command queue, starting with the requirements. The requirements are actually pretty simple. Command queue starts by putting an entire task, aka Automation1's version of a thread, into a mode we call queue mode. So naturally, to use this feature, we need to first have an open task to operate the command queue on. By default, all Automation1 controllers have access to at least 4 tasks. With additional software upgrades, this can be increased to 32 tasks on PC-based controllers and up to 12 tasks on drive-based controllers. The order of operations on how a command queue operates is also pretty simple. After you start and add commands to the command queue, it then executes them on a sequential first in, first out basis. So the first command inputted into the queue will be the first command executed on the controller. The second command inputted would be the second command executed, and so on and so forth. Once the command is executed, it then leaves the queue permanently, and the user will need to reload another command into the queue to be executed. Another thing to mention is that when we do put the task into queue mode, the task will be primed to start looking at the command buffer so that it can execute them as soon as a new set of commands is loaded. No need to worry though, there are additional commands with the command queue that allow us to start and stop and pause the queue manually, so there's no need to worry about your commands executing from the queue before they're ready. But while command queue is active on a particular task, there are restrictions that apply to using command queue. You cannot use non-queued AeroScript commands in a task under queue mode. AeroScript programs cannot run on a task under queue mode. More details on this part later. You cannot use the retrace feature. You cannot use the interrupt motion feature. You cannot use the AeroScript sync statement to execute a function on a controller task where a command queue exists. You cannot declare any AeroScript variable, strict enum property or function from command queue. And while not necessarily a restriction, AeroScript functions apply all relative file system paths as absolute paths instead. We also cannot use typical programming statements like if, while, for, and repeat loops, among others, while using the command queue. Nor can we use any of the program commands that can control the state of another AeroScript program. So with all of that background and knowledge of what the command queue is and the basics of how it functions, how do we actually use it? Well, as we already discussed, to use the command queue, you need to use the command queue methods of the C or .NET APIs for beginning the queue, setting it up, and loading it with new commands. This is done just like any other motion command in the APIs, except it is preceded by the command queue method. In this example, using the C APIs, we initialize the command queue on task 1, pause it to prevent unwanted execution, load a move linear command or two into the queue, and then resume the queue execution. And that's what we can see here. On line 8 we begin the queue, on line 9 we pause the queue, 10 and 11 we load new commands into the queue, and then 13 we resume. And the only difference between this and a non-command queue method is the preceding Automation1 command queue phrasing where we're declaring the Automation1 queue commands. While the previous slide showed a command queue version of the move linear command, this slide shows the normal version of the move linear. Generally, we initialize the queue first. This involves both setting up the size of the queue and the task that it runs on. Then we pause the queue to prevent unwanted command execution. We add commands, and then we resume the queue to start the execution of commands. We also find that it is best practice to use the command queue wait for empty function to wait for the queue to fully finish before continuing on to the next line. This is just to make sure that the queue completely empties all the commands before we end the command queue. And this should be done before any time you end the queue. Then, after all is said and done, we can end the queue. This command also has the added possibility of being able to abort the command that is currently executing and discard any remaining commands left in the queue. And that is the basics of how command queue is programmed. We initialize it, pause it, load it, resume it, wait for empty, and then we end it. Now there are also a number of things we can do on top of this too. Earlier we mentioned that you cannot run AeroScript programs on a task when it is under queue mode. That is only half correct. While it is true that you cannot run a normal AeroScript program on a task currently under the control of command queue, if you had a custom AeroScript file containing all of your command queue command lines, then you can execute this file. But it still needs to adhere to the restrictions we talked about earlier, dealing with if, for loops, or program commands. For instance, to execute a large pre-written AeroScript program, we can just use the Automation1 command queue execute from MDK file command. This command is also simple to use. After we begin the queue, we can just use this command to specifically target the program file that we wish to run. In our example, we are targeting a program with a list of PVT commands to run at 20 kHz. Then, like before, it is best practice to wait for that queue to empty, i.e. the program to finish. Alright, let's go jump and look over at a more detailed example. So with this program I have right now, this is the basic form of using the command queue. So as we discussed, we begin the command queue, and I'm doing this on task 1, and I'm making my total buffer size of the command queue 5,000 lines long. I then pause the command queue, and then I load a bunch of commands into it. Now these commands are pretty straightforward. I enable velocity blending, I enable my axis, I give some move linears, I disable the axis, and then I turn velocity blending off. After which I resume, wait for it to empty, and then we end the command queue. So pretty straightforward. Begin the command queue, start it, load some commands, resume, and then wait for it to empty. Now something like this is pretty straightforward and simple to do. But if we wanted to go ahead and look at something that is maybe a little more useful, in my opinion, for running the larger sized programs. So for that, we can use this execute from MDK file command. This command, as we discussed, will allow us to look up a certain program at a specific location and execute that program as an Aeroscript file in the command queue. Now what we'll notice here is I'm actually running mine as a text file. We can accept either a text file format or an Aeroscript file if you already have one written. Now this particular program here, medium text test, is just a long list of repeated G1 commands. The big part here though is to notice that this total line count of this program is about 300,000 lines long. So I'll constitute this as a medium to large size program. So let's go ahead and run this and see how it goes. Now, what we might see when we're looking at this is also this 1000 here at the end. Well, 5000 at this command queue begin line signifies how large the queue is by itself, how much of a buffer size we want to take up. This 1000 is simply how many lines per call into this medium text test program, into our specified program here, that we want to grab and load into the queue as at once. So every time we go to load new commands into the queue from this execute from MDK file, we can select how large that chunk of commands is going to be. So for much faster command execution, so if you're trying to run programs that are executing at 20 kilohertz, you might want to use a value of 1000 to be able to load enough commands per call to sustain and keep the command queue full. For smaller, simpler, slower commands, 1000 is going to work just fine, maybe a little overkill, but it really doesn't harm anything. Now, what we'll also see here, if we go over to the status utility, is a couple items indicating what the command queue is doing and what's actually going on. So down here, if we go to tasks, we can go to the specific task that we're running on. In this case, I guess I'm actually running this on task 2, not task 1. But we can see that we have a command queue capacity of 5000. That matches up with our signified value of 5000. We can also see the command queue unexecuted count, executed count, line number, and then the times emptied. The unexecuted count and executed count are simply a way of telling us how much is still in the queue and how much has been done. Now for this particular example, because I'm using the execute from MDK file command, we can actually look at this command queue line number signifier here to see which line in the program we're actually on. Now we won't wait for this command queue times emptied to tick up, because that would require us to go through the full 3000 lines of the program. But every time we do empty the command, either intentionally or if we're not keeping the command queue full and it empties on accident while we're still trying to run a program, you can use this command queue times empty to actually see if something like that occurs, and that might link up with a delay in the process or the program. And to top it all off, if we jump over to Automation1, we can see that our axes are moving per the command in the command queue. So that is the basics of what an example with command queue in the C++ or C APIs will look like. And that is, in essence, what the command queue feature is. A simple concept that loads and executes commands from a queue to run large programs, reduce command overhead from the APIs, or to store commands in a buffer ready to execute. That concludes this motion control platform educational video. Thank you for watching, and I hope you enjoyed learning about what the command queue feature is and how it operates.